Today in my class, we worked on understanding variables. Variables in computer science, well, it's different than variables in math. Kind of. And that was the point I wanted to make with this assignment. So I'll go ahead and link this assignment in the description, right? So I'll link a Google Doc to it if you would like to make a copy of it to either do yourself or for your students. It will be down there. Okay, I'm going to go ahead and work my way through it. But again, if you want to copy it, I'll link it in the description. So variables vary. I was pretty proud of the name of this assignment. Let's start with question 1. Question 1, obviously, is just a simple variable problem from math. So 9 plus x equals 10. So what plus 9 equals 10? Well, in that situation, x must be 1 because 1 plus 9 equals 10. Let's go ahead and change my pen color. There we are. Okay. So that must be 1 because 9 plus 1, well, equals 10. Next up on 2, 4 plus x equals 20. Therefore, let's see, it looks like x must be equal to 20. Right? So these are just simple variable problems. X on problem 3, x minus 5 equals 3. What could x be then? Well, what minus 5 would equal 3? Well, that would be, if you want to do the math part of it, you could obviously just add 5 to this side. And so x is going to be equal to 8. Okay? So, and then this question 4 over here, answer in math. What answer in math x is used as a variable? Oftentimes we see that in math problems. Do variables like x always equal the same thing? Well, do they? If we look over here at this first problem, x here, right? X equals what? Well, we said x equals 1. And obviously, at least for this problem, x can only equal 1, right? Because x plus 9 equals 10. So it's not like I can say, well, x equals 1 and x equals 6. No, x doesn't equal 6 here, right? That's not possible. X has to equal 1. However, as we change, as we use x in different problems, so we use it here, then we used it in this problem and this problem, right? We can keep using x in all sorts of ways, and x will equal different things. X will mean different things. In math, x is used as a variable. Do variables like x always equal the same thing? Okay? And I'm not going to write out the full sentence. A sentence was expected from students. No. Variables change. Right? And obviously, I would want more detail than this. I would want at least a sentence. So maybe variables change depending how they're used. Variables change in different problems. Something like that. But the basic idea is no, variables do change. So what do we have here now? We have, some more variable stuff. Solve. So question 5 is cow plus 2 equals 4. So what would cow be equal to then? Well, cow must equal, well, what plus 2 equals 4? If I subtract 4 from this side, subtract 2 from this side, and subtract 2 from that side, I find out cow then must be 2. Because 2 plus 2 equals 4. All right. 4 plus snow equals 14. So what must snow equal if 4 plus snow equals 14? Well, in that situation, snow must equal 10. Because 10 plus 4 would equal 14. Now I got creative and I use this smiley face. We spruce it up a bit. Ooh, I'm not sure I'm going to be able to. But regardless, we have a smiley. 8 plus smiley, right? 8 plus smile equals 15. So what would smile equal? Well, if I subtract 8 from both sides, 15 minus 8 equals 7. So that means our smile over here has to equal to 7. Now, on to question 8. Answer. Does it matter that we use variables other than x, such as y or cow? What can be a variable? Well, does it matter? I had a few good points. So, x is certainly a variable. In math, you'll see y. In math, you'll see z sometimes too. Or t. I've done some math problems with t. All sorts of things will work as variables. Okay, usually in math, one letter is the variable or one symbol. Usually it's not a full word, but there's no reason that I can't use a full word for a variable, right? And there's also no reason, usually you won't see a smiley, but there's no real reason I can't use something like, ooh, that error was rough, something like a smiley as a variable. So, does it matter that we use variables other than x? No. Comma. And I'm just going to do something short. Variables can be something like many different things, right? And again, my students should have something better than this. So students, if you're watching, I would want more explanation. I'm just hitting the basics. So for students, and the expectation would be something more like, no, variables can be x, y, z, cow, and symbols, as long as they're representing something. That would be a better answer. This is a simplified answer, not the quality that I would want you to have. The dog runs. So now I'm on 9. The dog runs. She is a fast dog. Yes, creative sentence. Now, the clover runs. She is a fast clover. What does clover must mean? Well, if we look up here, if this sentence was the dog, yikes. This sentence was originally the dog, right? And then up here, she is a fast what? Dog. So the blank runs. What's missing? She is a fast, So what this is then, what this symbol means, what this variable must be, is dog. Okay, so now we're using a variable to equal a word. Or in code, you might say to equal a string. We'll get there. Now I'm on to 10. 10. Can a variable represent a word? Well, look over here. Okay, look up here. Can a word be a variable? Yes, we've already said that. Does a variable have to be equal to a number? No. A variable can represent more than numbers. More than numbers. Okay? So a variable can be more than simply numbers. All right? Now, we're going to make our own definition for what a variable is. What is a variable? Write your own definition. Answer must be at least 2 sentences. I'm not going to go through this piece by piece, but what I would say is you want to look up above. So 4. In math, x is used as a variable. Do variables like x always equal the same thing? So I would say something about a variable is, I don't know, maybe, let's go with a different color, maybe representing something else. So in math, x is a variable. Do variables always equal the same thing, right? So no, variables change. They can equal different things. Does it matter that variables other than x, y, or such as y or cow are used? No. So variables, variables, then I would say something about variables being symbols that stand for something else. Okay, so obviously x is standing for a number here. Cow is standing for a number. So it's some type of symbol that means something else. They can change And they can be letters or words. Variables can be different things, something with that. Okay, and they can represent more than just numbers. So basically, what this is, you should be tying in. Okay, all together, you are tying in 4, 8, and 10, talking about what you think 4, 8, and 10, and talking about how variables represent other stuff. Okay, let's keep going. All right, we're on to question 12. How many times will the fake code on the left print hello world? We're getting to the more difficult stuff. So let's see what we have here. Let's grab this guy. Number is 0. So right now, number is equal to 0. Is number less than 3? Okay, well, number was equal to 0. So is 0 less than 3? Yes, it is. So if so, okay, print hello world. Oh, so if so, print hello world. All right, so I'm going to go ahead and print hello world then. So cool, printed that, check, we printed it. Number now equals what? Well, it equals 5. So number now is equal to 5. Is number less than 3? Well, so number is now equal to 5. Is 5 less than 3? Hopefully, nope, it's not. So if so, print, we can ignore this. Number wasn't less than 3 there. All right, let's see what our question is then. How many times will the fake code on the left print hello world? Well, we went through it all, and we have a check here that it printed hello world, and then, but it didn't print down here. So how many times will it print it? It will print It will print. Oops. It will print it once. Excuse my bad handwriting, and we can get rid of that. So it will print it once, right? It's going to print hello world once. Okay, let's keep going. Now let's see. What do we got over here? Is this one? var, so this is JavaScript. Depending on what programming language you're learning, you might be in Python. My students, we're learning JavaScript. var right here, that's making our variable. So variable count. So we now have this new thing in the computer. We've created this variable in the computer, and then we've set our variable equal to 0 because count, equals 0. So wall count is less than 3. Well, was count less than 3? I don't know. Let's see. Count equals 0. So wall count is less than 3. Is count less than 3? Yes. All right. We just set up here count is equal to 0. So yes, count is less than 3. Let's drop down and see what we do next since it is less than 3. Print hello world. Okay. We will do that once. So I'm going to just put a little tally here of our prints. Count equals 8. So count now equals 8. And I just hit the bottom of my loop, which means I got to go whoop, whoop, sound effects included, back to the top where the bracket is. All right, now I got to check it in again. Wall count is less than 3. Well, count here became 8. So is count less than 3? No. So now we stop. If there was code down here, that's when the program would skip through the rest of this loop and start running all the code beneath it. But there is none. So we only got to run this code one time, right? Because at the beginning, when we made our variable way up here, count equaled 0. We said wall count is less than 3. Oh yes, count is 0. That is less than 3. We then drop down into this. The only way we could run the code in between this bracket and this bracket is if this was true. So when count was less than 3, this was true. We printed hello world our one time here. Okay, and then we said, oh, count equals 8 now. Fine. Hit our bracket, went back up to the top. If count is less than 3, nope. Count was now equal to 8. So we only printed hello world one time. The code on the left will print hello world one time. Why? You should have something about, I'll say something about count. Ooh, I need a thinner one. Try this again. Count is changed to be 8. Okay, so it will print it once at first because count is 0, like we said, but then once it runs through all this, count becomes 8 and we are done. It can't print it again. It goes to the top of the loop, says nope, count's not less than 3, and doesn't print it again. Okay, let's see what else. The code on the left will print looping 5 times. Okay, so we're going to print looping 5 times. Why only 5 times? VAR x equals 0. So again, VAR is the creation of a variable. This is JavaScript. In JavaScript, VAR defines a variable. What variable did we create? Well, we created a variable called x. What does x equal? 0. We said create this variable, x. X is now equal to 0. Okay, let's see what our code does. Wall x is less than 5. Okay, well, what is x currently equal to? We just said it is equal to 0. So, yep, x is less than 5. We will drop down into this, and it says print looping. Print looping. Okay, I'm going to go ahead and write that over here. So that will print, well, looping. Okay, that will print looping. Students, keep in mind when we are working on our code in the computer, you don't want to use this print statement. That is just for this paper stuff. Print looping, all right? So I have looping over here now because I printed it once. Okay, now I'm going to drop down x equals x plus 1. Well, x was originally equal to 0, so 0 plus 1 is 1. So at first, x equaled 0. Now, since x equals 0 plus 1, the new x variable, or x is now equal to 1. Okay, so now we're going to go back up here. We hit the bottom bracket, so we got to go up to this bracket up here now and rerun it. While x is less than 5. Okay, well, what was x equal to now? X is equal to 1 this time. So that's less than 5, and we are going to print looping again. Okay, so we print looping again. We now go to this next line, x equals x plus 1. Okay, well, x was 1. 1 plus 1 equals 2. Okay, so now x equals 2. And I should note, when did we print these? When I printed that looping, x was equal to 0. When I printed this looping, x was equal to 1. So now I hit the bracket. I got to go back up here. While x is less than 5. Well, what does x equal? Well, it now equals 2. Is 2 less than 5? Yes. So we drop down, print looping. All right, so right now x equals 2. I am going to print the word looping. Okay. Now I'm going to drop down again to the next line. X equals x plus 1. What is 2 plus 1? That is 3. So now I hit the bottom of the bracket. Go back to the top. While x is less than 5. Is 3 less than 5? Yes. So I can go back into the loop, print looping. Okay. So x right now is equal to 3. I'm going to print looping. Okay. And then we're going to go down a line. X equals x plus 1. 3 plus 1 equals, well, 4. Hit the bottom of my loop, this bracket thing, go back up here, curly bracket, back up here, wall space, x is less than 5. Well, x currently equals 4, so yep, that is true. I drop into this, print looping. Okay, so now while x equals 4, I print looping. All right, now I go to the next line. X equals x plus 1. 4 plus 1. Well, now x equals 5. I hit the bottom of my curly bracket. I go back up to the top of my loop. While x is less than 5. Wait a minute. What did I just say, though? X is now equal to 5. Our code is done running this loop. So we now can skip. This would be false at that point. If x equals 5, x is not less than 5. That is false. We would now, the code skips this and starts running whatever code's down here. All right, so let's read this again. The code on the left will print looping 5 times. Why only 5 times? I would have this saying something. It prints it when x equals 0, 1, 2, 3, and I'm going to go off a bit, and 4, right? Because we start way over here, we started at x equals 0. So when it runs through at 0, it prints it once, twice, third time, fourth time, fifth time, then it says x equals 5 and ends our loop. Okay. Now, 15. How many times will the code on the left print winter? Number equals 0. Same situation here. I'm going to go a bit faster. If number equals 0, while number is less than 3. Is 0 less than 3? Yes. So it drops down. It's going to print out the word winter. And right now, number equals 0, winter. We have it printing it out once. And then it says number equals number plus 1. So number was 0 is now, well, now it's 1 because 0 plus 1 is 1. Hits the bottom of this and the curly bracket, goes back up to the top of our while loop. While number is less than 3, number is currently equal to 1. 1 is less than 3. It's going to print winter. I'm going to write 1 because right now number is 1. Write winter. Okay. And then number equals number plus 1. Well, number was 1 right now, so number plus 1 equals 2. Hit this curly bracket again, go all the way back up here. While number is less than 3. Well, number was 2, so yes, it is less than 3. Print winter, so I'm going to write 2, and then winter. Okay, number equals number plus 1. Well, it's 2 right now, so number is 2 plus 1 is 3. Is 3, hit the bottom of the curly bracket, go all the way back up. Is 3 less than 3? No, that would now be false. It would stop running the loop, and if there's code down here, it would run that. So, how many times does the code on the left print winter? 1, 2, 3 times. My students need to make sure that's a sentence. All right. Variable z equals 1. While z is less than 8, print school. Print school. All right. The computer will try to run this code forever. Oh, forever. It's going to try to never stop printing it. Why is that? So, why is that? Well, let's see here. If we go over here, look at this loop. While z is less than 8. While number is less than 3. Let me clean this up some so we can see. Okay. While number is less than 3. Did we define it? We defined number as 0. Do we define z? Yes. Z is 1. Okay. We then print something out. Print school. We also printed out winter here, and that code ran. Number equals number plus 1. What's missing here then? We don't say anything about z. That means we set z equal to 1, which is fine. Z equals 1 here. We then run it. Is 1 less than 8? Yes. So this would print out school. So z equals 1, and we're going to print out school. Okay. We at the bottom of our curly bracket here, we go back to the top of our loop. While z is less than 8, what does z equal? Nothing has changed to z. Z still equals 1. So we go into our loop, drop down, and we print school. Okay? We hit the bottom of our loop, this curly bracket. Whoop. While z is less than 8, what is z still equal to? We never changed z. We never added anything. Z is still equal to 1. And so it's going to print out school. Okay? Hits the bottom of the loop, goes back to the top. Is z less than 8 still? Yes, we never changed z. Z is still equal to 1. We print school. Goes to the bottom, goes back to the top. Is z still less than 8? Yes, z equals 1. We print school. Okay, we go to the bottom, go back to the top. Z still equals 1. Z is always, always, always going to equal 1. 1. Ooh, that was bad. But nothing ever happens to z here. Nothing changes z. We do make z. We have variable z equals 1. However, we never add or change it at all. So the reason this code is wrong is z, yikes. Let's say z never changes it will always be less than 8. It's always going to be equal to 1. So therefore, it will always be less than 8. Okay. And our last one is 17. In the box on the left, write a loop that will print my loop 6 times. Alrighty, my loop 6 times. So we need a variable. What variable? Let's say variable c for count equals 0, bracket, semicolon. Now, while statement. Now we need it to print c. We need it to print 6 times. So since we're starting at 0, if c is less than 6, we should be good. We're now going to do a curly bracket, or I'm going to try to. Yikes. Close enough. That should be a curly bracket. Okay? And then what do I need to do? I need to print my loop 6 times. I'm going to write print my loop. And I'm only going to write it once because we're using a loop. We're not actually just going to repeat ourselves. Now, I need to be careful here. This is where I need to take C and say C equals C plus one, semicolon. And that C equals C plus 1 is what's going to make sure C keeps going up. Now I need a curly bracket here to end it my loop. So it's going to go C equals 0. Is 0 less than 6? Yes. It's going to print my loop once. So when C is 0, it will print, I'm just going to say my. Now it goes down here, C plus 1. Okay, well, C was 0, so now C is 1. 0 plus 1 is 1. Goes back up to the top of our loop right here. Is 1 less than 6? Yes. So while C is 1, it prints it again. Drops down. C equals C plus 1. Well, C was 1. 1 plus 1 equals 2. So C is now 2. It goes back up here. Is 2 less? Yes. It prints. And it keeps going until it reaches 6. So 3, 4, 5, and it stops once it equals 6. Wait a minute though, does that print it 6 times? Yes, because it prints it here at 0 once. The second time is when C equals 1. The third time is when C equals 2. The fourth time is when C equals 3. The fifth time is when C equals 4. And the sixth time is when C equals 5. So in the box on the left, write a loop that will print my loop 6 times. I guess I don't need to write anything there. My loop is there. Okay. And that actually should do it for this assignment. I am going to go over the looping assignment that we did in CodePen, where you are going to change and make your own loops. So that should be somehow linked. Maybe below this video, I'll put a link to that, or at the end of this. That will also be posted.